Hello, today we're going to be talking a little bit about summarizing some data. So let's say we've gone through some process and we've collected some data. For example, we've all set a test and the test was out of 20, and here are some raw scores that we've collected as our data. If I wanted to summarize this data, well, summarizing any data, I have to kind of look across three separate domains. So first, we'll talk about location. So location of data, that's essentially saying where the scores are centered on a number line. So examples of measures that tell us where scores are centered on a number line are the mean, the mode, and the median. The average, the most common, and the middle value all tend to sit somewhere relatively central on a number line. Oh, sorry, not central on a number line, but show us the center of the data on a number line. So here's an example. There's a green set of data, -4, -5, -6, and there's a blue set of data, 1, 2, 3. When I speak of the location of this data, I'm literally talking about where it is on the number line. And the median of the green data would be -5. The median of the blue data would be 2, for example. Same with the mean, because it's symmetric. And so that median and mean value would give me a kind of idea of the center of the data on a number line if I didn't have a diagram of it. Next, we'll talk about shape next. We're not really going to delve too deep into shape, but I'll just give you a kind of quick rundown. So when we're looking at, for example, histograms, um, we tend to pay attention to the shape of the data. Some key things we look for: symmetry or asymmetry. And if we see that some data is asymmetric, we might be interested in what direction it skews in, or what direction the tail of our data seems to head in. But that's a story for another time. More importantly, though, for our purposes right now, is the spread of some data. So if there's some data and I asked, what's the spread of that data? Well, I would be asking for the range and the interquartile range. So let's say, for example, here's a number line in red, and I've got my data sort of spread out across that number line. I'm interested to know how my data is spread out across the number line. So the range, it tells me the total or overall spread from the smallest to the biggest. How far does my data spread across the number line? And the interquartile range, that tells me a little bit about the central spread of my data. So the middle 50% of my data, there's about 50% of data in this region. And the interquartile range is telling me how that middle 50% is spread out. A little bit more on spread. We could calculate the 5-figure summary, which we'll talk a bit more about in a second. But this 5-figure summary, as you can see, we calculate the minimum, quartile 1, quartile 2, quartile 3, and the maximum. These are all the key features on our box plot. So that's why, I'm going to be talking about box plots next lesson, basically. So that's why we're connecting these two things together. Because when we summarize statistics, when we find the 5-figure summary here, it's all the key features on a box plot. Alright, so some notes to take down. The 5-figure summary. I didn't actually finish writing these notes. So 5-figure summary, we have our minimum, which is the smallest, quartile 1. This is the median of lower half. And the quartile Q2, that's the median of the full set of data. Quartile 3, that is the median of the upper half. And the maximum, that's the highest value. So there's your 5-figure summary, and it kind of tells us, first of all, it breaks up our data into quarters, and it kind of shows us the spread across all of those 4 quartiles. Again, when we summarize data, we tend to look at the location or the center of the data, the spread, how it ranges across our number line, and also we look at the shape. But for our purposes in our class, we're looking mostly at the location or the central tendencies of our data. Here are the most common measures of center or location for data: the mean, the average, Sum of all of the scores, divide by the number of scores. Median, when we arrange our data from smallest to largest, the median is the middle value, and the mode, that's going to be our most frequent score. For spread, we have range. This is defined as, didn't finish these notes either. Oops. The maximum subtract the minimum, the interquartile range. This is going to be quartile 3, or the median of the upper half, subtract quartile 1, or the median of the lower half. And standard deviation, that's another measure of spread, but we'll get into that in a future lesson, because that's quite a big topic. Alright, so a bit more notes. So when we have continuous data, and we speak of our data in intervals, so here I'm talking about all the possible values between 1 and 10, and all the possible values between 11 and 20. So for example, we are going to be describing data that's going to fit nicely onto a histogram. It's going to be continuous. Well, first of all, our frequency table, we see that it's set up in intervals. So when we calculate our measures of center, like our mean or our median or our mode, we calculate based on the interval, not the specific score. So what do I mean by that? The most common, the mode in this instance would be the scores with frequency of a 9 here, because that's the highest frequency out of all of these. We see that's the interval 31 to 40. So we'd say the modal interval, or the modal class, is 31 to 40. Right? We wouldn't say the mode is some specific number. We say the modal class is 31 to 40. And if I were to calculate the mean and sum together a bunch of scores and divide by the total frequency, I would sum the midpoint of each of these scores. So for example, the midpoint of 41 and 50, I would just find the average of 41 and 50. That would be 45.5, I believe. Yeah. Yep. And I would say this 8 times plus the midpoint of this guy 7 times plus the midpoint of this guy 8 times, and so on and so forth. So I would just assume that all 8 values in this interval were on the midpoint, and I'd assume all 9 values here were in the midpoint between 31 and 40, and so on and so forth. I'd be summing up the midpoints rather than trying to think about what specific numbers go inside the intervals, because I don't know, right? But anyways, moving on. Let's talk about actually finding the summary statistics, or the 5-figure summary. Let's speak about finding that now. So, for example, here's a set of data. We kind of saw earlier the minimum was the smallest value, quartile 1. That was the minimum. Sorry, the median of the first half. Quartile 2, that was the median of the full set of data. Quartile 3, that was the median of the final half, or the upper half. And finally, the max was the largest value. We could find some measures of spread, looking at the figures calculated with the 5-figure summary. The range is the maximum value subtract the minimum. So here it would be 10 take 1 would be 9. And the interquartile range would be the upper quartile subtract the lower quartile. Q3 take Q1. In this case, 9 take 2.5. 9, 8, 7, 6.5 would be the interquartile range. Alright, so let's calculate all this for ourselves. So if we were to find a 5-figure summary of some data, how would we do it? The first step would be to arrange data. We need to arrange it in ascending order. So looking through here, I see 4 is going to be the smallest, followed by 6, followed by another 6, followed by an 8, followed by a 9, a 10, 2 12s, a 14, 16, and 19. So if I were to arrange my data from smallest to largest, I see I would have, well, this arrangement as you see here. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11. Cool. So we've arranged our data in ascending order. Now the minimum, clearly going to be the smallest. The maximum, clearly going to be the largest. The median, that's going to be the middle value. So if I've got 11 data points here, I can kind of guess that the median is going to be around the 5.5 mark, right? Because that's about half of 11. So if I count up 1, 2, 3, 4, 5, and this is my fifth data point, I'm just going to start from here. I'll see I've got 1, 2, 3, 4 data points behind. I've got 1, 2, 3, 4, 5, 6 data points beyond. So that means my median is more likely going to be this 10. So let's check. 1, 2, 3, 4, 5 points below. 1, 2, 3, 4, 5 points beyond. So our median here is going to be 10. We could have also just counted off in either direction until we reach the middle, but whatever floats your boat. Okay, so now when I'm looking for the median of the lower half and the median of the upper half, if my median of the full data set, my Q2, if it falls on a number 10, I'm going to actually exclude this 10 in my search for Q1 and Q2. And so what I mean, when I'm looking for Q1, I'm only looking out of these numbers. I'm excluding that 10. Okay, and I see out of the median of these 4, 6, 6, 8, 9, these numbers, my median or my middle number is going to be 6. 2 on the left, 2 on the right. That's going to be my Q1 or median of my lower half. Okay, same thing when I'm looking for the median of my upper half. I actually don't include my Q2, my median of the full set. And I can see that 14, that's going to be the median of my upper half. Alright, great. So now that I have got my 5-figure summary, let me just pause. Oops, sorry guys, I just had to check my notes real quick. But anyways, so now that we got our 5-figure summary, we can just easily create a box plot off of this. So this is going to be very rushed, but we just need a number line down the bottom. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You know, I'm really rushing this. It should be ruled, and obviously the markers should be evenly spaced. Four, 5, 6, 7, 8, 9, 10, 11, 12. Yep, and we can just place each of the 5 figures as vertical bars on our number line. 4, 5, 6. It's going to be Q1. 7, 8, 9, 10. There's Q2. 11, 12, 13, 14. Q3. And then the maximum 19. What we're going to do, the middle 3 bars, we're going to connect them up to make our box. And then the whiskers are going to be connecting our box to the minimum and maximum. There's our box plot, and as you can see, it just shows us a spread of not only all of our data, minimum to maximum, but our middle 50% of our data. This is 50% of our data, right? Because we've got quarters, 25% here, 25% here, 25% here, and 25% here. So it really shows how our data has been spread out. Okay, one more thing on box plots for this video is just going to be, what if we have an even number of data points? Well, all that's going to mean is it's going to mean that when we find our 5-figure summary, we got min, we got max. Okay, now the median, well, we got 2, 4, 6, 8, 10, 12. The half of 12 is 6, so I'm going to look at around the 6th number. 1, 2, 3, 4, 5, 6. And I'm going to see below we got 1, 2, 3, 4, 5. Above we got 1, 2, 3, 4, 5, 6. If I look at, what above, I got the opposite problem. 5 above, 6 below. So the median here, it lies it lies between the 10 and 12. The middle number is in the middle of 10 and 12. And we can probably see in the middle of 10 and 12 is clearly going to be 11. But if we couldn't see that, obviously, we just need to find the average of those two numbers to find that our median, when it lies between two numbers for an even set of data, it's going to be the average of the two numbers it lies between. So in this case, it's going to be 22 divided by 2, that's 11. Alright, so now what does that mean for finding the Q1 and Q3, lower half's median and upper half's median? Well, it means that now the data we are looking at to find the lower half and upper half, it includes this 10. So we see that we're going to have a median between 6 and 8. Average of 6 and 8 is going to be 7. And it means we include this 12 when we look for the median of the upper half for Q3. We see it's going to lie between 14 and 16. That is going to be 15. Alright, so we'll also talk about finding outliers, but this is getting a bit long, so we'll do that another time. Peace.